Hey guys, Tyler here. I'm back. I haven't forgotten about you. Unfortunately, my Mini back there finally got clogged and I'm gonna have to take the hot end apart. I thought, this would be a good opportunity to go ahead and upgrade to an E3D hot end. Looking online for one and I came across a really good deal. It finally came in the mail today, so let's take a look at it. Now, this is a little bit bigger than I thought it would be, but I'm told that there's an E3D inside of this thing. So let's check it out, see what this thing's all about. And up on top, we've got, thanks for your order, standard deal. Unfortunately, they still included a junk spool of filament, which you should never use because it's not enough to do anything with. Let's see what else we've got in here. Power supply. Now this looks significantly different to the original one. Let me grab the original one. So this is the V1 power supply, and this is the V2 power supply. Now, they are really different. I can tell you that the V2 definitely feels sturdier. I don't know that they're going to be necessarily that much higher quality, but just from reading the outputs, the original one was rated 12 volts at 10 amp, and the new one is rated 12 volts up to 7 amps. That's a bit interesting. And it looks like the new one's rated for 95 watts versus the old one being rated for 120 watts. The other interesting bit is the leads. The new one looks like it's not a grounded power supply where the old one was. That's honestly a little bit worrying, but let's have a look and see. See what else we've got in here. Nope. So there's our power cable. It is 2-prong USB cable, filament, spool holder, spudger tool, little SD card that is not even labeled this time around, Allen wrench, and then we've got the unit itself here. So it's fundamentally the same chassis, same print volume, all that good stuff. New color, obviously. But let's pull it out. And let's bring the V1 over here, do a little side-by-side comparison. And the biggest differences are that you can see the new one actually has a fan, which is awesome. So we don't have to worry about the stepper drivers overheating and shutting down after 20 hours into a 40-hour print, which is pretty fantastic. Other than that, the back is basically unchanged. We've still got same kind of power cable, although I have to say I like the new jack for the power cable a little bit better. One thing that they absolutely improved is the USB port. So a common problem on Minis with the original USB cables is that you couldn't actually get them in because the USB port was so recessed in there, and I'm happy to report on the new one, they fixed it. It's actually flush mounted, so you have plenty of room to plug in your USB cable. That's quite nice. So from the front, controls are largely unchanged. However, the dial is significantly better. It actually has enough room where you can grab it and turn around the edges. Feels like it's got the same button and everything, which is okay, I guess. Really, it looks like almost everything else is fundamentally the same. They definitely haven't made any major changes to the plastics up here. So it looks like we may still have similar problems with the extruder arm potentially breaking, but everything is Phillips head screws, which I hate. That just means for all of us who want to mod this or do any work on it or need to repair anything, these things are going to strip out. we're gonna have to replace them. It's gonna be a pain in the butt. I really, really wish they had standardized on hex screws, but what are you gonna do? I'm gonna go ahead and spend the $10 or so to switch all mine out for hex screws because I hate dealing with Phillips head screws. They strip out and they're worthless after about 3 uses. Also a little stinky that for taking the whole chassis black, they used black screws on top, but they used silver stainless screws for the sides. That just looks a little bit off. I wish they would have fixed that, especially considering that on the bottom they actually used black screws. Be nice to be consistent there at least on these guys a little bit. So let's get into the meat and potatoes of this. So it does have what feels like a generic build tack surface on it. I'm going to be really interested to check this out. One, to see how level the surface of this aluminum plate is, because on both of my original minis the plate was not flat, which is why I ended up having to go with a glass plate. So when we go to level this for the first time, we'll see if they've actually done better in manufacturing with keeping the plate flat. And then the star of the show here is the hot end. Supposedly this has a E3D-like hot end or a J-head hot end. I'm really excited actually to see what it's gonna look like, especially because in a video coming up shortly, I'm gonna be replacing this hot end with an authentic E3D hot end. So we can do some compare and contrast to see how this guy measures up to the real deal. Let's have a look at the hot end itself. So from the outside, I can tell pretty much right away that it's not an authentic E3D hot end, but we're gonna keep digging. So I'm gonna pop the fan clips off of here. There's one. There's the other. So let's pull these off so we can get to the hot end itself. See if this thing's really cooking with gas. There we go. Yeah, it's definitely a clone. It is an all metal hot end. This thing is either Loctited in or somehow is torqued down, as well as the hot end down here is not giving me a ton of confidence either. So that just means if you do ever need to take this out or readjust things, I have a feeling this is going to be a pain in the butt to deal with. One nice thing, actually, one really nice thing, is the way that they have treated the thermistor here with this little cover plate. I actually do like that quite a bit. That's a really nice way to protect it if you're moving things around here and there. So kudos on that. The mount here, honestly not the greatest because even though you've got a fan mount on there, there's this little 30 millimeter fan. If you look at an authentic, grab one over here. If you look at an authentic E3D hot end, basically the way this fan operates is that it has almost no moving resistance behind it. It needs open air behind it so that it can actually push air through. And the way this thing is designed, you're basically pushing air into a cavity with not a lot of evacuation behind it. So, you know, we'll see in the real world if that matters or not, but it's definitely going against some of the design principles of the E3D cooling to mount it that way. It actually would have been a much better mounting scheme if they had done like a side mount so that it could push air either one way or the other and not be blocked by the gantry itself. These are almost like wood screws in their threading, which is a little worrying because it means that probably going to be pretty easy to strip these things out. Again, I really wish that they had stuck with machine screws and with hex head machine screws on this. And it's still single fan to cool the hot end and as a part cooling fan. A little bit disappointing, I feel like they could have at least moved us up to a 40 mil fan. I can understand why they didn't have separate fans for part cooling and hot end. That is quite a bit more expensive to do. It definitely would have been nice to have a bit beefier fan on here, because this isn't going to do a whole lot for part cooling, that's for darn sure. But overall, it's definitely significantly better than the V1. Another small thing with the spool holder, looks like I'll still be making another spool holder with my roller skate bearings, because they didn't change the spool holder or make any improvements to it. Having that smooth roller on there just makes such a big difference. If there's any kind of catch or snag or anything on your spool and you're just using the stock spool holder, that can ruin your print in a hurry. So that's another thing that could have been improved on a little bit more. So let's plug it in and see how it works. Definitely like the plug a lot better, for sure. It's much more snug this time around. Although I have to say, I really liked having the right angle on the plug, because now not quite as out of the way as it used to be. When you turn it on, it's firmware version 30.50b. We do have a firmware revision. I'm going to be interested to see what's in there, what's different. Of course, the most important thing here is we need to peel off the screen protector, because without that, you just can't do anything. We've got the same menuing system that we've had before. It's exactly the same. There's really no change whatsoever to the menus. So let's see how level this is. So all I've done is home all axes. We're just going to start with our paper test. Just see how far off this thing is. One thing I'm noticing already is they haven't fixed the alignment issues with the bed. So I've got probably a solid 2 centimeters of build tack behind the distance that the hot end can travel, but it's sitting just on the front lip where the edges of the 120 millimeter build volume are. I really wish they had brought this forward. Even just another like 2 or 3 millimeters actually would make quite a bit of difference here. Yep. The build plate on this thing is bowed. I hate to say it because I'm really excited to try out the build tack, but it's right on the edge of even being usable for me. I guess for now, really, all I can do is try to kind of meet it in the middle a little bit. Now, one nice thing is that fan is actually doing its job pretty well. Like, I can feel the airflow through the chassis, so that's definitely a positive. Okay, so I've got a print loaded on the SD card here. Pop that in. Got a fresh spool of black PLA from Hatchbox. I've already got everything up to temperature, which normally I actually wouldn't do, but since it's the first time this has ever been loaded up, you can already see there leftovers from the factory. Come back out to our SD card menu, and load up our file and start printing. So this should only take just a second here. Just gonna knock that little bit off. So it's just printing at standard settings. So 205 on the hot end, 60 degrees on the platform, 97% flow rate. So this is the same settings I would use on my other Mini. And we'll see how this fares. Now, I'll note on here, I've done no adjustment to the PID tuning settings. This is just as it came out of the box about an hour ago. So the fact that I'm able to print out of the box is already a huge leap forward from the V1. All right, I'm gonna go ahead and cancel the print because it's already too messed up to continue. I've got the bowing is just too bad on the outer edges here, so I'm gonna have to try to offset that. And It's also apparent that I need to adjust the retraction settings a little bit to reflect the different style of hot end, and we'll come back and give this another go in a second. I've gone back, lowered the temperature a bit, adjusted the bed again to try to find a happy medium, reloaded the SD card. So let's see how this goes. So one thing I'm noticing is that the bed temperature hit 57 degrees Celsius, and then I guess that triggered the hot end to begin preheating, which is now causing the bed temperature to fall. It's now fallen 7 degrees to 50 degrees Celsius, and now we're beginning to print. And now it's jumping right back up 52, 53, 54. So I don't know if it actually turned off the heat to the bed, or if it's just that because of the smaller power supply, if maybe it just doesn't have the current to drive both at the same time. Yeah, so the bottom off, having a look at the board here. The one thing I'm immediately noticing is there is an extra populated fan header, which is what they're using for the exhaust fan on the case, which is interesting. So what I'm probably going to end up doing is actually using that line instead for powering the extruder fan, and then using the extruder fan as my part cooling fan line, since there are two fan headers, and the current extruder fan is one that you can actually do speed control on potentially. It's good that there is an extra header there, so there is some flexibility, so that we could hardwire a 12-volt fan in if we wanted to. So that's a pretty good thing. It looks like they've gone with a smaller motor for the Y-axis, and it doesn't use a standard connection. I've yet to see a pinout like that on another NEMA 17 motor. That's pretty interesting. It looks like we have the same motor for the Z-axis. It's mounted the same way. Not a whole lot of difference outside of that. It looks like we do have actually a slightly different assembly for the screen and dial, but nothing fundamentally different there. And we do have a heat spreader now. So between that and the fan, no worries about this thing overheating. I'm already noticing too, just from a single print, that we're already starting to get a little bit of wear and tear on the belt for the Y-axis. This is common in the V1 as well, although I've printed probably 100+ hours on each of my V1 minis, and even though they still show some wear after that time, I've had no problems with anything mechanically on them. So that seems to go well. I'll also say that the insulation that they've put underneath the bed here looks like it actually makes a difference. This thing still isn't fast to heat up, but it definitely is consistent. It was basically a linear ramp up to 60 degrees Celsius. Kudos on that. That's a definite noticeable improvement over the V1 as well. So now I'm going to take the tower off, because the one thing I heard rattling sounds like it's the Z-axis rods, and I just want to see how those are mounted. So, very interesting that they've changed out the motors for the X and the Y axis with these guys. They're not quite NEMA 17 pancake motors. I'm not exactly sure what they are. They seem to have a pretty non-standard connector as well, but so far they seem to do the job. A little bit of a letdown that they dropped down to a smaller motor, but then again, honestly, the the weight that these are carrying or lack thereof, didn't really need much. The ones that were in the V1 were honestly overkill. Just like with the V1, the Z rails have a little bit of slop to them, and we've got a little bit of wobble on the Z axis. Although in the prints, there's no Z wobble at all in the first print that I did anyway to try this out. So let's just give this a little bit of a move on the Z just to check it. Just to see what we're working with here. Yeah, there's definitely still some Z wobble, but it looks like that's just due to a slightly out of tolerance rod. Just looking down at the connection down here, unlike on the early V1s, the coupler actually looks like, at least on this one, looks like it's in pretty good shape. You can see now that I have the front panels off, as the Z goes up and down, you can see the wobble. I think given the design, definitely the coupler they're using now, this was also in the later model V1s, doesn't really need to be touched or upgraded. So it's a good sign that at least that hasn't gotten any worse. While this coupler works, I really wish they had gone ahead and upgraded to just an integrated lead screw that would take any of the vibration out of the equation. I've been living with the Monoprice Select Mini V2 for over 6 months now. I ordered the V2 on its launch day and received one of the first run units, so it's possible that some of the kinks have been worked out, as Monoprice is known for making small improvements from one production run to the next. So let's start with the new stuff. First and most visible is the new hot end, an all-metal E3D clone. It definitely isn't a real E3D V6, but it is an absolutely massive improvement over the V1 hot end. No more worrying about PTFE liner issues, temperature limits, or heat creep. Plain and simple, it prints like any E3D V6 Bowden setup does. Same quality, same behavior, but with one serious issue. The thing is impossible to disassemble. Malian must have assembled this with JB Weld epoxy because I couldn't get the heat break to unscrew from either the heater block or the heatsink. I was seriously worried about breaking the hot end, and I decided I'd rather have a functional printer than risk pushing the limits to try and pry it apart. Second, the cooling fan for the hot end is still ducted to act as a cooler for both the heatsink and printed parts. This was a really poor decision on the V1 and even worse for the V2. The 30mm 0.1 amp fan just doesn't have enough airflow to pull double duty, and it still operates in firmware as a part cooling fan. This results in dangerous situations where the fan can turn off completely during prints. Heat creep on E3D style hot ends happens incredibly quickly, and clearing jams from heat creep is a serious pain in the butt, made worse by the inability to take this one apart. The cooling fan isn't sufficient for printing PLA with adequate cooling for bridging and steep overhangs, and the design of the fan mount is really poor as well. Airflow is already restricted, and the duct design reduces it to a level that I seriously worry about it being able to adequately cool the hot end, much less the printed parts. One simple improvement is to swap the fan connectors for the mainboard and hot end fans. The mainboard fan is always on, making it a much better connection for the heatsink fan. I plan on swapping the 40mm mainboard cooling fan for a 50mm blower fan and using a duct and tubing to split the airflow to provide a part cooling fan as well. The V2 also has a generic reinforced PET mat applied on top of the aluminum build plate, along with a small amount of insulation under the heated bed PCB. The mat works extremely well for adhesion on PLA and PETG as is. It also works well for other difficult materials like ABS, nylon, and flex filament with a layer of glue stick applied. However, it's a very cheap addition. The mat began delaminating from the build plate after my second ABS print, forcing me to re-glue or remove it. I would have preferred that Monoprice just go ahead and use a piece of borosilicate glass with some kind of clipping mechanism. This would solve several issues with the printer that I'll get to in a few minutes. The electricals have seen a lot of improvement as well. The power supply is all new, using a non-grounded outlet, and it actually operates within its specifications, 12 volts, 7 amps. unlike the V1's 10 amp rated power supply that routinely actually pulled 13 to 14 amps during operation. The new power supply should be much less likely to fail in operation, and in my testing is much better built. The firmware is also much more solid. In my case, a beta version and seemingly the last revision before Maoyan moved to a significantly different UI platform. The PID settings for both the hot end and bed were properly tuned and accurate straight from the factory, so no more painful firmware updates are necessary. Just turn it on, load your G-code, and print. In the new UI controller, a lot of annoying bugs seem to have been fixed as well, though I've been unable to confirm this firsthand. Even more good news is that support for both the V1 and V2 will be coming built into Cura starting with version 3.2. So you guys won't have to worry as much about initial setup and configuration of your slicer either. However, it still isn't perfect. Simple things in the firmware like access limits are still missing, and it's still proprietary and closed source and has no official support for updates from either Maoyan or Monoprice. Last on the new feature list is the Mainboard Cooling Fan. It works well along with the heat spreaders on the stepper drivers and eliminates any possibility of overheating on the mainboard. That was a common issue with early V1s. So that's all the new stuff inside the V2. But there's a lot more to this printer. There are a lot of improvements and a lot to be happy about for sure. But this printer isn't all rainbows and butterflies. The list of problems with the V2 isn't very long actually, but they are major and they're not cheap to remedy. The Z-rod and coupler on the V2 is the same as my later generation V1. There's not even a hint of Z-banding on this unit, but I'm sure like the V1, there will be quite a bit of variability in manufacturing, so you may still need to add some stabilizers to the Z-rod, but hopefully replacing the coupler won't be necessary anymore. I'd still like to see a proper coupler for the Z-axis, or even better, an integrated lead screw into the Z-axis stepper motor. At the volume this printer is being manufactured, it should be cheaper to go this direction than continuing to use independent parts and coupling them together. The heated bed is still warped, just like on the V1. This negates a lot of the value of the included build mat, as you'll either need to flatten the bed yourself or use a glass sheet to achieve a level, printable surface. I opted to flatten the bed on my V2 so I could make use of the build mat and fell into another world of hurt. The heated bed on both versions of the Mini uses a PCB bonded to a thin aluminum sheet. This makes adjusting the surface really easy to do. In fact, it only took me about 5 minutes to flex the build plate back to flat. However, if you attempt this, you're going to crack the surface mount thermistor almost every single time. It's cheap to replace at only $2 to $3, but it boggles my mind that anyone would use a surface mount component on a flexible surface like this. If you do replace the thermistor, use a glass bead type with lead wires and glue them down to allow for flex. You can check out a future video, hopefully, on how to do this. In my case, the warping was bad enough that I had to go through this pain in order to use the entire print volume. I also had to sand down the edges of the build mat because it had a slight lip at the edges from cutting that caused it to catch on the nozzle and made leveling difficult. The stepper motors for the X and Y axis are new, smaller, and non-standard. They are still the same NEMA 17 form factor, but they have a much smaller height, usually indicative of lower torque. I didn't notice any functional difference, but I worry about the longevity of these steppers over time. The printer is also noticeably louder than the original, due in part to the machining residue that was all over the Y-axis rods on my unit, but also owing to the fact that it has smaller torque stepper motors. After a good cleaning and lubrication, it was much more reasonable, but still significantly louder than the V1. It's got Wi-Fi on board, just like the V1, and while technically working, it's still an afterthought with a very poor user experience and extremely limited functionality. I've been working on a solution for this for a while, and hopefully I'll have some more news about that in the near future. The included 256 meg SD card is garbage and should never be used. It is, from my benchmarking, a Class 2 device with 2 megabyte per second write speeds and 2 to 4 megabyte per second read speeds. Ditch it and buy literally any name brand replacement. A 16 gigabyte Class 10 SanDisk Ultra card can be had for about $10 with free shipping on Amazon. The same goes for the included sample filament. It's too little to print even the CAT G code included on the SD card. Monoprice should really swap this out for cleaning filament to help with filament swaps and clearing clogs over time. But all of these issues are, while frustrating, really pretty small and easily resolved for beginners. The real deal breaker is the power supply. It is a better part, but it simply doesn't have the amperage to drive this printer properly. Both the hot end and bed each pull over 6 amps at full load. As a result, the printer can't actually heat both at the same time or maintain the temp of the bed while the hot end is heating up. This isn't really an issue for PLA, but for any material that needs a bed temperature over 70 degrees Celsius, you're not going to be able to print. You can get a beefier power supply to fix this, the best alternative being an Xbox 360 or Xbox One power brick, which is inexpensive, but requires soldering on the correct DC power jack to fit the Mini. The V2 is undeniably a better printer than the V1. There are fewer issues, and for newcomers to 3D printing, the issues that remain aren't likely to be a problem getting started. But they are issues that limit the printer's capability significantly and can all be resolved with cost-effective solutions from the factory. It needs a much beefier power brick, or a move to a 24-volt system, or an internal power supply. It needs a better quality bed, or a glass plate to solve the issues with warping on the print surface, and a non-SMD thermistor to allow users to adjust the bed and flex it over time. It needs proper part cooling, independent of the heatsink cooling fan. Without this, the Mini isn't able to do bridging at all and can't effectively print complex PLA, PETG, or ABS objects. But that's not what we have today. Instead, we have the V2. So, should you buy one? Well, if you're only planning to print PLA and you get a little lucky in getting a bed that isn't badly warped, the V2 is, in my opinion, the best PLA printer you can actually buy for $200. It requires almost no setup, upkeep, or tweaking to produce consistent, fairly high quality PLA prints. If, on the other hand, you want to print with any other material, be prepared to spend some time and money to get there. It cannot print ABS despite the claims on the Monoprice website. The inability to keep the heated bed up to a usable temperature results in warping that will delaminate the build mat, cause massive cracks in the print, and will fail almost every single time. To unlock the potential of the V2, you'll need a soldering iron, an Xbox power supply, and a piece of borosilicate glass. The power supply will cost you $25 to $30 on Amazon, and the glass is about $20 from Go3D Print. At $275, it's no longer the incredible value that it could be, but it's still less expensive than any of the pre-assembled alternatives. The real question comes down to initial cost versus operational cost. There are many kit printers that are significantly less expensive with larger build volumes. There are dozens of Prusa i3 clones that can be had for under $150 and on paper offer the same functionality with 4x the print volume. But they all require significant time and money to build, debug, tweak, and upgrade the kits to get them reliable. There are also a handful of pre-assembled printers with similar volumes to the Mini V2, but none of them offer heated beds and are all limited as a result to PLA. So, there you have it, the Monoprice Select Mini V2, a good printer at a good price that still has room for improvement. Let's hope that Monoprice gets it right on the third iteration. And please give us open source firmware. If you like this video, make sure to subscribe and hit that thumbs up button, and check out the rest of the V2 videos I have coming soon.